Okay, so the first thing there, which is this question about the potato. This is identical. Again, the short answer question on the midterm will be exactly this question. The only things that are going to change are the molarity, what the solute is, and the temperature. Same formula. You will have a formula sheet. So if you remember our solute potential formula, negative ICRT, keep in mind it's always 100% of the time going to be a negative answer when you're doing this, and your units for this are always, again, 100% of the time going to be bars. So don't lose points for like those little mistakes, forgetting that it's negative and forgetting your units. So let's walk through this one really quick as an example. I is the ionization constant. What would that be for sodium chloride? It would be 2 because it splits into 2 ions. What if I told you it was glucose or sucrose? Then it would be 1. And honestly, it's either going to be NaCl or it's going to be glucose. So that's all you have to know. I won't give you something weird like ammonium, something funky, nothing like that. Just it's either going to be something that's 2 or it's going to be glucose or sucrose, which is going to be 1. So that's our first number. So that's going to be negative 2. C is the molarity, so that's going to be 0.25. You're just going to plug that in. R is the ionization constant, 0.0831. And then T, don't forget to change your temperature to Kelvin, so that's going to end up being, sorry that's messy, but 293. It reminds you on the formula sheet to change it to Kelvin, so that shouldn't be a problem either. You literally just plug in those numbers, and on this one you get negative 12.2. I'll let you know where to round on the AP exam. Remember, they don't ask you to figure out sig figs or anything like that. So if you ask me, I'll tell you, oh, just round to the 10th place. It doesn't matter. 10th place, 100th place. So that's the first question. The second question that you would be asked is if the pressure potential is, and again, I'll probably change this number, 10 bars, what's the water potential? So the water potential is just the solute plus the pressure. Technically, if you get your solute potential wrong, you're going to obviously get the wrong answer for this also, but I'm not going to penalize you. If you understood to take your answer from here and plug it in as your solute potential, I'll give you credit, based on whatever you got. So in this particular case, it should be negative 12.2 plus 10. So the water potential should be negative 2.2. And again, your units are going to be bars. This answer could be positive or negative. Obviously, it's going to depend on the size of the other number compared to your number. But it's going to be exactly this. All I'm changing is a couple of numbers. So just make sure you know how to plug stuff into the formula. So any questions about that one? Okay. So then the next thing is this. This goes along with it. So if you go to here, you will have, it won't be, it's not going to be 6 of them. It's just going to be 3. I'm going to have you a table with 3 beakers, supposedly, of solutions, and I'm going to ask you to calculate the percent change. You will not have to graph it. So even though on the review sheet it says graph it and determine C, you won't have to do that. But you will have to figure out which is what you had to do on the test. In other words, this won't be here. It'll just be 3 beakers with changes. So you have to remember how to put them in the right order. If I say which one was the pure water, or which one was the, if I say the 3 beakers had, let's say one had pure water, one had 0.2 molar sucrose, and one had 0.4 molar sucrose, and I say tell me which one was which, you have to know how. So how do you know which one's the pure water? Do you remember? Here's the numbers, by the way. The highest percent change, exactly. So these are the numbers. Technically on this one, I don't know why. I think I may have made a mistake when I plugged the numbers in, because this goes like obviously down and then it comes back up again, which technically it shouldn't do. But I promise it won't do anything weird like that on the test. So you'll get 3 points. I'm pretty sure I have 3 points just for calculating the 3% changes. Remember, that formula is not on the formula sheet. So that's final minus initial over initial times 100. So that's another formula that you need to remember. A lot of people made mistakes on this because they divided by final instead of initial. This can be a negative number. If it lost weight, it's going to be a negative number. If it gained weight, it's going to be a positive number. Yes?
Would the lowest molarity go to the lowest percent change, or does that?
It's vice versa. So pure water, and I'm going to show you this actually on in a second, but pure water will always be the one that gains the most. And I'm going to show you on another slide in 1 second why that is. If you had to graph it, which you don't have to do, but just if you did it on the review, it would look like this. This is your 0.2, 0.4, 0.6, 0.8. This would be your pure water. This would be your percent change. And the whole point of the graph when we did this in the lab was that wherever it crossed the x-axis, that was C. And that was what we estimated the molarity of the potatoes to actually be. So that was the purpose, but you will not have to make a graph on the test. So, but there are a couple questions on the test about percent change. So calculating them is one thing. The other question you're going to be asked to do is to put them in order. So just to show you, here's what you would expect. Let's say you had a potato, and the potato you knew was 0.15 molar. If I put that 1.15 molar into 0 molar pure water, what should happen to it? Should it gain weight or lose weight? It should gain weight. Remember, the rule is that water always goes towards hypertonic. And that potato would be hypertonic to the water. It has a higher molarity than the water. So it should gain weight in the pure water. In fact, again, this is how you'll know which is which. The potato will always, even if you didn't know what the molarity on the potato was, pure water is going to be the one that's always going to gain the most weight. What if I put 0.15 into 0.10? So this is 0.15. It's still hypertonic, right? So it's going to gain, but it's going to gain less. And now what if I put it into 0.2? Now it's going to lose, and if I put it in 0.3, it's going to lose even more. So that's how you're going to know the order to put them in. You're going to get your 3% changes, and you're going to put them in order by saying which one is the pure water, or which one was the, I don't know, if I told you these were, let's say these were the 4, and I say which one is the pure water, or which one is the 0.3, or whatever, the one that's the highest molarity is going to be the one that lost the most weight. The solution that's the pure water is going to be the one that gains the most weight. So that's how you'll know which is which. So any questions on that? And that'll help on a multiple choice question as well. All right, so then I want to show you one other thing with this. You're going to have a multiple choice question with a YouTube. So you may or may not remember the YouTube problems of that chapter. So in a YouTube problem, you'll always be given a little reading. Make sure you pay attention to what the little reading says. So in this case, the little reading says that sodium chloride in water can pass and glucose cannot. That's going to be important information. You're going to be asked 2 questions about the picture. And the amounts are going to be different, but in essence, it's going to be similar to this. First thing you're going to be asked is which side at the beginning of the experiment is hypertonic. Is it A or B at the beginning before anything moves? So which one would it be? How do you know? You know how to figure it out? Yeah, which side at the beginning of the experiment before anything moves is the hypertonic side? Right, exactly. All you got to do is you're going to add up your percents, or if it's molarities, add up your molarities. Whichever one has the higher number is your hypertonic side. So in this diagram, side A is the hypertonic side at the beginning of the experiment. If they were equal, it would be isotonic. It won't be, though, I'm telling you, on the test. One of the sides is going to be hypertonic to the other. The second question that you'll be asked about this will have to do with which way stuff's going to move. So first, which way would sodium chloride move? It would move towards side A, correct. Because any solutes that can move are going to go from where there's more to where there's less. So sodium chloride would go to the left. How about the glucose? Make sure you read the reading. Correct. So glucose will not go anywhere. That's always going to be a trick question. I know, her bows are in the way. All right, and then the last thing, assuming that water can pass, water is going to go to the hypertonic side. So which side is water going to go towards? So water is going to go also towards A. You will never be given a situation where one of these things moves in a way that's going to change the situation. In other words, this is already the hypertonic side. The fact that that sodium chloride can pass isn't going to change that. It's It's going to make it even more hypertonic. Yes.
So, basically the hypertonic question is also going to answer with a water.
Correct. Yeah. And a lot of times they will say, they won't necessarily say the water will go towards A or B. They'll say, their way of saying it will be that the water level would end up higher on side A. Because if water goes towards side A, the water level would go up over there.
So everybody goes to hypertonic.
So water goes towards hypertonic, and then any solutes always are going to go from where there's more of that thing to where there's less of that thing. So solutes go from more of the solute to less of the solute, and then water will go to the side basically that has the most solute. In essence, that is going to be the side with less water. But it's easier just to remember that water goes towards the hypertonic side, so once you've figured out which side that is, it's easy to know that's the way water's going to go. All right. So that'll cover, there's going to be a U-tube, and then there's going to be another one with like dialysis tubing in solutions. As long as you understand the slide we just did, this one, you should be fine with that one too. As long as you understand which ones would gain weight and which ones would lose weight, you'll be able to answer that question. And that will help you, like I said, with a short answer, but it'll also help you with that. That'll give you at least 4 or 5 multiple choice questions that cover that particular chapter. All right. We already did this. So we're going to talk next about, let's see where my time is at. I'm at 11 minutes. Okay. Actually, we're going to talk about the energy graph, which is here. This picture on the short answer, it'll be the same picture. All I'm going to change are those numbers. That's it. And I also forgot to add units on this, so there'll be units. But it'll be the same thing. So the first question you would be asked about this is whether it's endergonic or exergonic. So what is this one? This is exergonic. Because the products have less energy than the reactants. So it's exergonic. For delta G, technically it's going to be this. It's going to be this amount. But it's negative. This was a frequently asked question on the last test we took. It said, which of these is true about the graph? And one of the options said delta G is, I think it was 25 on that particular graph. That was not the right answer because delta G was negative 25. Delta G for this one would be 50 minus 150. So it would be negative 100. And again, the units, I didn't have them on the review, but there will be units there. So it would be joules. Activation energy will always be a positive number. It's going to be section A. So for this one, it's going to be 50 joules. It's just this distance. You will literally be asked this exact question. Draw a line indicating what an enzyme would do. All you have to do is make any line that's lower than the first one. Just make sure that it does merge with the first one. Because enzymes don't change delta G. In other words, it would be wrong if you did this. If you somehow made it lower and ended lower. That would be wrong. So make sure it starts off and ends with the first line, but it's lower than the first line. It just lowers that activation energy. You will not have a question like this one where you have to calculate the entropy, so you don't need to worry about that. You will have a regular delta G question. So it'll say, it'll be like, I believe it's the last question here. This one. The very last question, it'll be identical to this. Except I'll change the numbers. I'll give you S, I'll give you H, I'll give you the temperature, I'll ask you for delta G, and then I'll ask you if it's spontaneous. How are you going to know if it's spontaneous? Exactly. So if your answer's negative, it's spontaneous. It's 2 points. One for giving me delta G, one for telling me if it's spontaneous or not. This formula, remember, is on the formula sheet. So it's a matter of just plugging in the numbers. That's all you'll have to do. And the only other thing I wanted to touch on really quick, aside from this stuff, the other thing about enzymes you should know is, and if you got your test back, which you should have, make sure you know the labels on the enzyme. Almost everybody got it right, but that, like, this would be the enzyme. What would this be? The substrate. What would you call this area on the enzyme? Active site. And then when they're together, what's that? Yeah, an enzyme substrate complex. And then when that pops out, what's that? And then that's the products. So there's literally a picture of one of those, and that's a multiple choice thing. All right, so that, oh, I can't pause for